Hello everyone, welcome to my YouTube channel. In my first lecture on reduction, we have discussed some important reduction formula. We have discussed reduction formula of integration sine to the power nx, integration sec to the power nx, integration tan to the power nx. We have discussed these three important reduction formula in my previous class. Now, in my second lecture of reduction, we shall discuss two more important reduction formula. Okay, and you can check this formula from my YouTube channel. Video link are given in my channel. So, if you have not watched this reduction formula, then just go to my channel and watch this reduction formula. These three formulas are very, very important. Now, in my second class, that means in today's class, we shall discuss two more important reduction formula. My first one is, this is my first one, this is my first reduction formula. Reduction formula is for integration sine to the power mx into cos to the power nx. What is my formula? My formula is integration sine to the power mx into cos to the power nx. And then there is a limit. There is a limit on this formula. The limit is over 0 to pi by 2. Okay. The limit is over 0 to pi by 2. So in today's class, we shall discuss this formula and one more. Okay. So these two are formulas that we are going to discuss in my today's class. My first formula is this: integration sine to the power mx into cos to the power nx. So let us denote this formula by Jn. Okay. আমরা ধরে নিচ্ছি কি যে Jn হচ্ছে integration sine to the power mx into cos to the power nx. We are assuming this. Then, as we have done in our first reduction formula, okay, we have applied byparts method. Okay, we have applied byparts method to solve this integral calculus. I again repeat, you have not, you have not watched this formula, reduction of this formula, then just go to my YouTube channel and you can easily understand the logic behind this formula, behind this byparts method. Okay, I have discussed everything in details about byparts method in my first video on reduction. Just go and watch this video. So in my second video, we start with the formula of Jn equal to integration sine to the power mx into cos to the power nx dx. Okay. So আগের ক্লাসে আমরা এইটাকে নিয়ে আমরা ডিসকাস করব। Integration sine to the power mx into cos to the power nx. So as I know, we have to reduce this formula by byparts method. Okay, we must apply byparts method to solve this type of integration. So we shall apply byparts method for this. So if we apply byparts method, at first see that we can write cos to the power nx like this. Cos to the power n minus 1x. See that we can reduce, we can break this cos to the power nx like this. Cos to the power nx, then cos x. We can do this. So just writing cos to the power nx like this, cos to the power n minus 1x into cos x dx. Now if we apply byparts method, how we can apply byparts method? The byparts method says, first function, suppose this is my first function and this is my second function, suppose. Okay, we have discussed byparts method in my previous class. In byparts method, suppose we have assumed this one as my first function and this one as my second function. Okay, and one more thing, remember in this formula, m and n should be non-negative. M and n should be non-negative. They cannot be negative. Non-negative means what? Non-negative means either it is equal to 0 or greater than 0. Okay, non-negative. M and n are non-negative, and one more thing, they should be integers. Sorry, they should be integers as well. M and n are non-negative integers. That means M and n can be 1, 2, 3, 4, even they can be 0. But they cannot be negative and they are always an integer. Okay, there is an important condition. So if we break this integration by parts method, see that cos to the power nx can be written as cos to the power n minus 1x into cos x, and sin to the power mx remain as it is. After that, we shall reduce this by parts method. By parts method says first function. At first, write down the first function into integration of second. First function into integration of second minus integration. Derivative of first function. Derivative of first function. Then integration of second function. And then this dx. This dx comes from this integration. For this integration, this dx occurs. So this first function, then integration of second, minus integration, derivative of first function means this, then integration of this second function. That is called rule of by parts. We have done by parts in my previous class. So this is called by parts method. Okay. So we have applied by part method for this JN. Okay. After applying this, you have to integrate this. Okay. Now we shall integrate this product. At first, we shall integrate this product. How to integrate this? See that we are doing this here. Integration cos x into sin to the power mx dx. Okay, we are doing this integral here. Integration of cos x into sin to the power mx. So how to solve this integral? Let us take sin x equal to z. Let us put sin x equal to z. Now we know that derivative of sin x is cos x, then dx, and derivative of z is dz. Derivative of z is dz. See that. Derivative of sin x is cos x, then dx, and derivative of z is dz. So my cos x dx, see that my cos x dx become dz. Cos x dx, taking cos x dx together, we are getting dz. And my sin to the power mx is what? My sin x is z. See that? My sin x is z. So sin to the power m, that means that will be z to the power m, because we have assumed sin x equal to z. So if my sin x equal to z, what will be my sin to the power mx? My sin to the power mx will be z to the power m, right? And then integration of z to the power m is z to the power m plus 1 by m plus 1. Okay, integration of z to the power m, there is z to the power m plus 1 by m plus 1, and put the value of z here. My z is sin x. Z is my sin x. Sin x to the power m plus 1 by m plus 1. Say that. My z is what? My z is sin x. So my z to the power m plus 1, that will be sin x to the power m plus 1 by m plus 1. So this is my integration of this part. This part is integration of this part is sin x to the power m plus 1 by m plus 1. Okay. So we are applying this integration part here. My integration of this become this. If you have any doubt, you can ask your doubt in my comment box. Okay. In comment box, you can ask your doubt. I shall solve it. Oh, okay. In my next video. So this cos to the power n minus 1x remain as it is. For this integration, value of this integration is this. Sin x to the power n plus 1 by m plus 1. Okay. This portion remain as it is, and this integration become this. Minus integration. What is derivative of cos x? Now say that we know derivative of x to the power n is n into x to the power n minus 1. There is a derivative. So derivative of cos to the power n minus 1x is what? This n minus 1 comes here. Then cos to the power n minus 2x. Then derivative of cos x. Derivative of cos x is minus sin x. See that we are applying this formula, derivative of x to the power n. There is n into x to the power n minus 1. So just using this formula, this here my power is n minus 1. So this power n minus 1 comes here. Then x to the power gets, okay, power reduced by 1. See that? The power reduced by 1. So here my power was n minus 1. It gets reduced by 1. It becomes n minus 2 in the power. And by chain rule, we have to differentiate cos x. Derivative of cos x is minus sin x, right? Just pause this video and write down this derivative part. And this integration portion, what about this integration portion? We know that this integration portion is this. We have done is here. We have done this integration here, and we are putting the value of this integration here. Putting the value of this integration here. Okay? And then dx. This dx remains as it is. The value of integration, we are putting the value of this integration here. Just write down this integration. So my Jn become what? Now, some basic calculation. My Jm become what? This part remain as it is. Okay, this part remain as it is. This part is cos to the power n minus 1x sine to the power m plus 1x by m plus 1. This portion remain as it is. And for this portion, say that minus minus become plus. This minus and minus, minus into minus gives you plus. This n minus 1 comes outside this integration. This m plus 1 comes outside this integration. So this n minus 1 by m plus 1 comes outside this integral. And under this integral, we are left with what? See that we are left with cos to the power n minus 2x. Cos to the power n minus 2x. Then sin x into sin to the power n plus 1. What is the multiplication? Here power of sin x is 1. And here power of sin x is m plus 1. See that? Sorry, I can do it. Here power of sin x is 1. And here power of sin x is m plus 1. So 1 plus m plus 1 giving you m plus 2. See that? Here my power of sin x is 1. Here my power of sin x is m plus 1. If we add them, 1 plus m plus 1 giving you m plus 2. So my power of sin x become m plus 2. My power of sin x become n plus 2, right? Anyone, any problem from this calculation? If you have any problem from this calculation, you can ask me. See that? My power become this. Cos to the power n minus 2x, then sin x multiplied with sin to the power n plus 1. Here my power is 1, and here my power is m plus 1, m plus 1 plus 1, giving you m plus 2. Okay, done? So this is my formula of Jn. Just pause the video and write down this. So my Jn, after simplification, it become in this form. Now, how we can calculate this? Now I'm writing here. Now we can say that by first portion remain as it is. Say that my first portion remain as it is. Now, how to simplify the second portion? For second portion, say that keeping cos fixed, we are writing sin to the power m plus 2x by laws of indices. We are writing sin to the power n plus 2 like this, sin to the power n into sin square. See that? Sin to the power n plus 2 can be written as sin to the power n into sin x. Okay? We can write like this, sin to the power n plus 2x into sin square x. Right? So we are writing sin to the power n plus 2x, right? Sin to the power mx into sin square x. We can write like this. Okay. Now say that this first portion again remain as it is. Okay, you can write this. Plus n minus 1 by m plus 1. Now see that sin square x. How we can write sin square x? this sine to the power mx remain as it is. Sine square x can be written as 1 minus cos square x. Obviously, you can write this, no? Sine square theta, that can be written as 1 minus cos square theta. Obviously, you can write this sine square theta equal to 1 minus cos square theta. We can write like this. Sine square theta equal to 1 minus cos square theta. Then again, my first part remain as it is. My first part to remain as it is. Then for my second part, we are just multiplying them. How to multiplying them? At first, we are multiplying this with 1. We are multiplying this with 1, giving you this. Then plus minus is minus. We are multiplying this with 1, giving you this. Then plus into minus, giving you minus. Then we are multiplying this with cos square x. We are multiplying this with cos square x. Giving you what? Say that we are multiplying this with cos square x, this with cos square x. If we multiplying this with cos square x, by laws of indices, see that at first write down this sign part. And by laws of indices, you can see that the power minus 2 plus 2. When we add the power minus 2 plus 2, this becomes 0. And we are left with cos to the power nx dx. See that. I can repeat. At first, we are multiplying this with 1, giving you this. Then we are multiplying this with cos square x. What is the multiplication we are doing here? This multiplied with cos square x. Okay, if we do this, you can say that minus 2 plus 2 gets cancelled. Minus, because cos to the power is minus 2 plus 2. Minus 2 plus 2 can be cancelled. This becomes cos to the power nx. And sine to the power mx remain as it is. Right? If you have any confusion, you can ask me in my channel. Just multiplying. We are multiplying this with cos square x so that in minus 2 and this power gets added. Minus 2 plus 2 gets cancelled. We are getting the power sine to the power nx. Right? Then what is my form of Jn? See that in my form of Jn, first portion remain as it is. My first part is this. My first part is this. It remain as it is. And for second part, this become n minus 1 pi m plus 1 into integration cos to the power n minus 2x sine to the power mx dx. So that this multiplying with this, then plus into minus, giving you minus, and this portion in minus 1 by m plus 1, then this multiplied with this, giving you n minus 1 by m plus 1 into integration so integration sine to the power mx into cos to the power nx. Right? See that n minus 1 by m plus 1 into sine to the power mx into cos to the power nx. So this become my form of Jn. See that? This become my form of Jn. Okay, done. My Jn become in this form. Okay. Now, see that. Now we shall write the first portion. My first portion is this. Cos to the power n minus 1x into sine to the power m plus 1x divided by m plus 1. My first part, cos to the power n minus 1x sine to the power m plus 1x representing power. Okay. Sine to the power n plus 1x plus this n minus 1 by m plus 1 remain as it is. This n minus 1 by m plus 1 remain as it is. Now what about this? Compare this integration with my Jn. Say that. Compare this integration with Jn. You can see that here my power is m, here my power is also m, but here my power is n, and here my power is n minus 2. See that at first. This is my power m. Here the power is also m. But here in power of cos, the power is n. But here my power is n minus 2. So this becomes j. Actually, see that it will be more helpful if we denote this integral by jmn. Jmn, and this is imn. There is imn. Just correct this notation. Just correct it in this notation. Let us write this integration by jmn and this integration by imn. Now you can see that here my power m remain as it is, but here the power is n, but here my power is n minus 2. So this will be j m comma n minus 2. This will be j m comma n minus 2. So just correct the notation. That's it. Procedure is same. Just check the notation. There is my j mn and there is my I mn. That's it. So I can repeat. Here m remain as it is, but here there is n, but here it is n minus 2. So this will be j m comma n minus 2. And for my last part, you can see that there is totally my jmn. There is totally my jmn because here m is m, n is n. Compare this. It is my jmn. There is also my jmn. Here m is m, n is n. Okay, done. Say that. So just pause this video and write down this entire thing. Just compare. Here my power is m. Here my power is also m. But here my power is n. But here the power is n minus 2. That is why it becomes j m comma. Here n is replaced by n minus 2. So this portion becomes my j m comma n minus 2. And there is my entire jmn. Okay. And in left hand side there is also jmn. So I'm just correcting the notation, not the procedure. Procedure is okay. Just correct the notation. There is my jmn. So what we obtain? My left hand side is jmn. My right hand side are sides are this. Okay, this jm comma n minus 2. And that is my jmn. See that. So jmn equal to this plus this minus this. Now take all jmn together. This minus, just taking to the left hand side. Just taking the minus sign to the left hand side. This become my plus n minus 1 by m plus 1 into jmn. And for right hand side, this is my we are just taking this minus sign to the left hand side. So if we take the minus sign to the left hand side, it's become plus. So this becomes jmn plus n minus 1 by n plus 1 jmn. And my right hand side remain as it is. Just right hand side remain as it is. Okay. Now calculate this left hand side in rough. Just take the rough one. See that the left hand side can be calculated as take jmn common. If we take jmn common, it is 1 and it is n minus 1 by m plus 1. Just calculating the left hand side, we are taking jmn common. If we take jmn common, this become 1. And if we take jmn common, this become n minus 1 by m plus 1. And if we take LCM, this will be plus 1 minus 1 gets cancelled. This will be m plus 1. This. Just taking the LCM. If we take LCM, plus 1 minus 1 gets cancelled. My numerator is m plus n. And my denominator is m plus 1. So this is my left hand side after taking jmn common. Say that. After taking JMN common, my left hand side become M plus N by M plus 1 into JMN. This is my left hand side. After taking JMN common, my right hand side remain as it is. My right hand side remain as it is. Say that. My right hand side remain as it is. So this is my okay. My right hand side. Okay, so JMN, after taking JMN, this become my left hand side. My right hand side remain as it is. So we are getting what? Okay. Okay, so there is my left hand side and there is my right hand side. Okay, after taking this, this is my calculation for left hand side. Now see that here, what I can do, we can find out the value of JMN. So my value of JMN become what? My value of JMN become what? Just see that my M plus 1 cancelled from both the sides. My M plus 1 cancelled from both the sides. So my formula of JMN become what? Just divide M plus N. Just divide with M plus N. So if we divide with M plus N, my JMN become cos to the power N minus 1x sine to the power M plus 1x by M plus N. And if we divide by M plus N here, this will be N minus 1 by M plus N Jm comma N minus 2. Say that. N minus 1 by M plus N Jm comma N minus 2. Just dividing by this M plus N. This M plus 1 gets cancelled from both sides. We are dividing by M plus N. If we divide by M plus N, this is my formula for Jmn. See that? This becomes my formula for Jmn. So this is called my reduction formula for Jmn. Okay, just pause the video and can write down everything. But see that we need to find out IMN. IMN is what? My IMN is this. See that in my previous video, we have discussed about this. What is the difference between JMN and IMN? You can see that JMN is without limit. IMN is with limit. My JMN is without limit and my IMN is with limit. So that means what? That means this portion is my JMN. See that this portion is my JMN, but there is a limit. So there is the only difference between IMN and JMN. We have discussed about this in my previous video as well. Just put a limit over JMN. Just put a limit over this JMN, you shall get IMN. So IMN is limit over JMN. So this is my JMN. So put the limit over this. Put the limit over this. Put the limit over this minus put the limit over this. Because there is no other difference between J and I. In J, there is no limit. In I, there is my IMN. See that there is a limit. So we are putting JMN over a limit 0 to pi by 2. We are getting IMN. So what is the formula for IMN? This is my formula for IMN, putting a limit over J. Now see that we know at first we have to put this upper limit. We have to put this upper limit and we know cos upper limit is 0. cos upper limit, cos pi by 2 equal to 0, minus. If we put lower limit, we know sine 0 is 0. So if we put x equal to 0 here, my sine 0 will be 0. That means my entire first portion becomes 0. Because if we put x equal to pi by 2 here, my cos pi by 2 is 0. If we put x equal to 0 here, my sine 0 is 0. So this entire portion becomes 0. Okay, and 0 minus 0 giving you 0. And for the last part, put the limit over this because it is my constant term. It is my constant term. So put the limit over this. Put the limit over this. Just put the limit over this. So my IMN, my left hand side is IMN, right hand side is 0 first part. Okay. And sorry, and as you know, and there will be a plus sign here. Okay, as you know, there will be a plus sign here, not a minus sign. Okay. I'm giving you, okay, there's a minus sign. Okay, there's a minus sign by mistake, but that sign will be plus sign. You can check the calculation. That sign will be a plus sign. That is not a minus sign. So there will be a plus sign. Okay, I made a mistake. There will be a plus sign here. So plus sign here. So n minus 1 by m plus 1 remain as it is. And if we put limit over j, we shall get I. If we put limit over j, we shall get I. That means my IMN becomes this. N minus 1 by m plus n into IMN minus 2. Say that. Anyone, if you find any problem, you can ask me. Just write down the calculation. So just remember a simple thing. Put a limit over j, we shall get I. And see that this sign will be plus. There's slight mistake in this sign. You can check it. So this is my formula for IMN. IMN equal to n minus 1 by m plus n, IM comma n minus 2. So just go through this lecture video. So this is my important result. Look at this result is very, very important. And for last reduction formula, there's a last reduction formula. In our previous class, we have done 3 reduction formulas. This is my important one. This is my 4th one. And my last one is integration IN equal to, or JN, whatever, JN equal to integration x to the power n, e to the power ax dx. This is my last reduction formula. Integration of Jn equal to integration x to the power n, e to the power ax. How to calculate this? We shall again use by parts method. Now, we know how to by parts this. So here we shall take this one as first function, this one as first function, and this one as second function. Say that. This will be easier for us if we take this one as first function, this one as second function. Okay. And this also comes from Eilert rule. Eilert rule says exponential function is second function. And my algebraic function is my first function. See that. Just go through this rule. We know exponential function is my second function and my algebraic function is my first function. So x to the power n will be our first function and t to the power x will be our second function. So first function into second function. So this will be our by parts. So if we apply by parts method, this will be first function into integration of second minus integration derivative of first function into integration of second function dx. Okay, right? First function, this is my first function, x to the power n is my first function, into integration of my second function, minus integration derivative of first function, then integration of second function. Okay. We are just applying the formula. So if we apply the formula, see that x to the power n remain as it is. What is the formula of e to the power x? Integration formula. We know that integration of e to the power x is e to the power x. Then differentiate the power. If we differentiate the power x, there will be a in the denominator. There will be a in denominator. Because if we have to differentiate x, derivative of ax is what? Derivative of ax is a. And write down this a in denominator. So e to the power x by a minus integration derivative of x to the power n. This is n into x to the power n minus 1. Then integration of e to the power x is e to the power x by a. Okay, this is my simple by parts method. We have just applied by parts method here, right? Then what? Say that my first part remains as it is, x to the power n, e to the power ax by a. Say that, and for the second part, you can say that minus n by a can be taken outside. Under integration, we are left with this. Under integration, we are left with this. Say that, under integration, we are left with this. So my first portion remains as it is. My left hand side is jn, and for right hand side, this is n by a. Now, what about this? Compare this with this. Compare this integral with this integral. See that here my n is replaced by n minus 1. Here this is n and this is n minus 1. That means this will be my j n minus 1. Everything is same for these two integral, but only n is replaced by n minus 1. So this will be my j n minus 1. Okay, and this is my formula for this. It's a very easy formula. It's a formula of integration of x to the power n into the power x. So if my jn is this, my jn minus 1 will be this. And that's it. Okay, this is the formula of jn. Now I'm giving you two homework. Just solve this two homework, and we shall discuss about the homework in my third lecture video of reduction. I'm giving you homework. Okay, some home. Let us take some homework and solve it yourself. My first homework is, if jn equal to integration x to the power n e to the power ax dx, find j3. Find j3 means n equal to 3. Find j3. There is my first homework on this chapter, and there is another homework from this chapter. So just solve this homework also. My second homework is homework number 1 and homework number 2. If jn equal to this, find j3. The second homework is, let in equal to integration 0 to pi by 2 x to the power n into sine x dx. X to the power n into sine x dx. We are given in equal to integration 0 to pi by 2 x to the power n into sine x dx. We are required to show that you have to show in plus n into n minus 1 into I n minus 2. In plus n into n minus 1 into I n minus 2 equal to n into pi by 2 whole to the power n minus 1. It's an important question. Good question. If in equal to integration x to the power n sine x dx, show that in plus n into n minus 1 into I n minus 2 equal to n into pi by 2 to the power n minus 1. I'm giving you a hint. I am giving you a hint. Start with this integration. Use by parts. Use by parts. Okay, so how to take how to do by parts? There is my first function. There is my second function. Why? Because of eyelet rule. Eyelet rule says this is my first function, this is my second function. So if we eyelet rule, what we shall get is first function into integration of second, and integration of sine x is minus cos x. And take the limit over this entire part. We have done this in my, okay, we have done in our previous lecture video. Okay, take the limit in this entire part, not only in this sin x. Take this limit over this entire part. And okay, to the power n, integration of sin x is minus cos x. Then minus integration derivative of first function. Derivative of first function means derivative of this, which is n into x to the power n minus 1. Then integration of second function means integration of cos x is sin x is minus cos x. Derivative of first function, there is the derivative of first function. Then integration of the second function, this comes from by parts rule. Then again by parts this part. Okay, use by parts for this portion again. Use by parts for this portion again. Okay, we shall get this answer. Just giving you homework. Okay, otherwise we shall discuss about this in my next lecture video. Okay, and it will be my last lecture video for reduction. Just do this by parts. And that is everything for my today's class. If you have any doubt, I again repeat, just ask your doubt in my comment box. I shall solve it. Okay. So today, okay, this is everything from my reduction. And again, we shall meet in my third lecture video on reduction. For them, just solve this to homework. That's it. Okay. Bye bye.